All right, in my last video, I mentioned for procedural generation, I used the wave function collapse. And I even went as far as to propose that it is a algorithm for even beginners to start with and is a way for beginners to learn as I did with myself, uh, the intricate details of software engineering, just general development and Unreal. So what is a wave function collapse? Here is a Sudoku board. I'll be teaching using it. Now, a wave function collapse algorithm uses two ideas. It has an idea of superpositions, quantum superpositions, and the second law of thermodynamics, or entropy. And while these sound a bit overkill or complicated, I promise they're not. On this Sudoku board, we have 81 tiles. I have not selected a number for any of the tiles, and therefore each tile has a superposition of all possibilities 1 through 9. A 1, 2, 3, 4, 5, 6, 7, 8, and 9 can exist within each tile. That's the idea of superpositions. It's undetermined, we'll say, objects that exist technically in all states. And then when you determine one, that's its definitive state. So right now, not only do all have 9 possibilities, but we can represent that as each tile having an entropy of 9. Now, things start to change once we have a determined number. This 9 has affected the board in the way that Sudoku would. In the horizontal row, we see 9 can no longer exist there. Within its own box of 9 squares, 9 can no longer exist, and the vertical. We can now say this 9 has an entropy of 1. There's only one possibility, the one that we set. The rest of the affected tiles have an entropy of 8, as there are now only 8 options. We can go further by placing another number. With placing a 1, we now see 1s cannot exist within here or here. And we can show a little bit further where they can exist, same with 9s. But we also see that because a 1 and a 9 can't exist here, it now has an entropy of 7. Because it has been lowered down by 2, there are only 7 options, 2, 3, 4, 5, 6, 7, and 8 that can exist within these tiles, and these tiles. You can continue down the line, just adding more numbers, as would with Sudoku, and eventually we will hit a point in which there's only one option. Only a 7 can go right here. We know that for certain. So we'll place a 7 there. It had an entropy of also 1. And there we go. Now we've selected for this box, each of these having an entropy of 1, and now going forward and affecting the rest of the board. Because we just did it within this square, we can still see all 9 possibilities still exist within these squares. There are less here. It should be 6 in each. Same with here. And we could go further and see how it would continue to affect the board. However, where this matters for procedural generation is with this. Let me pull up another project real quick. All right, here we go. So we see here I have a tile set. This is the actual tile set that I use with my own project, my own game right now. Now, we see only certain tiles can exist next to one another. This tile cannot be next to this tile. It doesn't have the continuity. It could go here. We could have this tile here. We could even have this tile here. We could put that one right there. We could even put this one right here. It might be a little hard to see. There is a bit of a dot right there. We can put this tile right here. And we could put that one there. And now I, in my own little example, have run out of tiles to place. But we can now start to see how we can create a unique world. Things can get moved around. Let's do it like this. That's a little fun. So intriguing, right? We can have a little bit of a generating world almost that's creating based off of what can exist next to each other. Sorry, it's actually that one that would go there. Forgive me, I'm a little sick. It's a little hard to talk. But where this matters, similar to Sudoku, if we were to view this as a grid, where this is the first selected tile, we can now start to perform a algorithm based off of a rule set. The rules being tiles that can exist next to one another. So we select this one. This is what is randomly selected first. We then need it's collapsed, we'll say. We then need to update its neighbors. It has a top neighbor and a right neighbor. We know that there are a few options that can exist right there. That can go there, that can go there, and this. If we were to put it like that, that works. So it has 3 possible neighbors. It has an entropy of 3 with these as its neighbors. Its top neighbor, we know nothing can exist above it. No tile has a bottom that would go well with this. So we would have a blank tile and it would have an entropy of 1. Only that could go there. So that would collapse and then it would move on. Only blank tiles in this situation can exist above one another, so it would collapse all the way to the top. Then we would move on to right here. We want to focus on the lowest entropy first, and it being 1 would have the highest priority. The next was 3 right here. So then a tile would randomly get selected. We'll say this one got randomly picked. Now we do the same. This was the collapse of selecting the tile. Now we do the same update, wherein we see that only this tile, and this tile can exist to the right. So this right neighbor would have an entropy of 3. This top neighbor, technically this could exist there. So we'll say that one's 1, 2. So it has 2 possibilities that can exist above it. So it would have an entropy of 2. So we would want to move here. And then we could say this is what randomly got picked or collapsed. And then continue from there until every single cell. Remember, I don't have a visual, but we're going to just imagine that this is a grid cell with the size of each tile being a actual grid unit. So when every single one's collapsed, we would then have an environment. Now in my world, as you can see, everything is following the continuous flow of the tile set. Only this can exist next to that, and so on. And it creates a procedurally generating world. Now, there are a few errors that I have, but this works very well right now. We can find eventually one of the errors, the biggest errors of a wave function collapse is there can be cases where things get weird and it breaks because either your tile rules aren't put in correctly or it gets in a bit of a stuck situation and it has to try to place things weird. A perfect example would actually be this. If we were to start with this tile and then select this tile, but then select this tile, we run into an issue where we could select that tile, and I guess that could work. That doesn't look like the worst thing ever. But in fact, you know what? I'm making myself think maybe I'm okay with that. Nah, I don't really like that. I would consider this to be an error. You can't do anything with that. It has gone down and up, and it's created a little bit of a funky thing. We want there to be some space in there. So if my rule set allowed for this, then it would break, and it would no longer be able to generate because it would it would get in a place. If it placed this here, there would be nothing to place above it, as I don't want this tile to be next to this tile in this situation. So we'll implement ways of saving states and backtracking and such. That's a very important part of the wave function collapse. But with time, we'll get it to a point in which it will look something like this. So I will make sure to include this tile set, as well as we'll leave out the grass for now. Well, no, I can include the grass, why not? And I will start making videos on the steps to actually create this. It'll be a kind of lengthy. Yeah, it'll be kind of lengthy. It's a bit complicated, but it is a fantastic way to learn Unreal. So I would recommend giving it a shot and just sticking with it. Thanks as always for watching, and feel free to ask any questions if you have any, and I'll see you in the next video.